Differentials are also used in the study of error and relative error, which are often routine calculations in science courses. We'll illustrate a couple of these computations with a couple of geometric examples. Let's suppose the radius of a circular disk is given to be 32 centimeters, with a maximum error in measurement of 4/10 of a centimeter. So here's a rough sketch of a circular disk, and there could be error in that measurement or in that calculation. It gives a little bit of error of 4/10 altogether. So between these two dotted lines, there could be a 4/10 of a centimeter error. Obviously, this is not to scale, it's just a sketch to help you visualize what is actually taking place. Now our goal is to use differentials to estimate the maximum error in a calculated area of the disk. Here is the area formula for a circular disk. Notice it is a function of r, and it's a differentiable function. So if you differentiate the function, f of r, you simply get 2 times pi times r. Using the definition of differentials, we can actually get the theoretical change in area. And that theoretical change in area is called dA. Now the actual change in area is approximately this theoretical change. So we'll go ahead and substitute for this theoretical change. Notice 4/10 is simply 2/5, and when you do that, you could get this fraction here that indicates an approximate for the actual change in area. The actual change in area is approximately 128 times pi over 5 square centimeters. I didn't mean to say the actual change in area. I meant to say the change in error for the area is actually this quantity. What is the relative error in the area of this circle? The relative error is by definition the measured area over the theoretical area. That is delta A over A. How about I make this clearer by saying the measured error? Once you realize that, we're going to take this delta A over A and approximate it with differentials. And the reason why it's an approximation is because the actual A, or change in A, is approximated by dA. Simply substitute and simplify. You end up getting this expression here, 2 over r times dr. Now we know what dr is. Dr is also the actual change in the r direction, which was given to be 4/10. Substituting these quantities, we get our relative error right here is approximately this decimal number here, or 2.5%.